Good morning, or hello, folks, and welcome to Advent of Code in F Sharp, day 15. Yesterday, we left off with a bit of a sad day. As you can see, I still have not collected the gold or the second star for day 14. I was looking for optimizations in the wrong place, it turns out. I was looking for like patterns in the generated outputs. But yesterday evening, while taking the train home from work, I think I had my eureka moment. I just have not found the energy to code it up yet. But let bygones be bygones. We'll get that star another time. We'll come back to it later. Today I want to take a look at the day 15 puzzle. So let's keep looking at the future, shall we? So, day 15. Let me get rid of my bookmarks. There we go. Day 15. I'm not even gonna try to pronounce that. You've almost reached the exit of the cave, but the walls are getting closer together. Your sub can barely still fit though. The main problem is that the walls of the cave are covered in something, and it would be best not to bump any of them. What is this thing? It is a magical, mesmerizing creature. Oh yeah. It's like one of those Pokemon. Okay. The cavern is large but has a very low ceiling, restricting your motion to 2 dimensions. Okay. The shape of the cavern resembles a square. A quick scan of density produces a map of risk level throughout the cave, your puzzle input. So these are risk levels of collisions, yeah. We start top left as always, destination is the bottom right, and you cannot move diagonally. The number at each position is its risk level. To determine the total risk of an entire path, we just sum up of each position we enter, so not the starting position. Okay, yeah, makes sense. Your goal is to find a path with the lowest total risk. In this example, this sounds like a Dijkstra shortest path algorithm. So total risk for a path. What is the lowest total risk of any path from the top left to the bottom right? This sounds like a Dijkstra. Pretty large grid. Nothing we can't handle. That's what I said yesterday. Probably. Is this 100 by 100? Yeah, it's 100 by 100. Let's also grab the example. Where would part 2 take us for this? No idea, so let's not worry about it. Can we do a basic shortest path algorithm here? I think so. What would that look like? We start somewhere, so we have a location. Then we just... then we just jump to every unvisited neighbor. We can't jump diagonally. And we just keep track of the intermediate distance. Or no, for every point we keep track of the best path or the shortest distance. That will work, right? I think that will work. Is the input, what is the first number? It's different, it's a 2. So maybe let's keep track of the entire path. Or a 100 by 100 grid, that's what, 10,000 elements. So 10,000 shortest paths. I think this will still fit on a RAM stick. No problem. I'm like torn between should we only mark or only try to calculate the shortest risk level or the shortest path, or should we keep the path as well? That's what I'm currently contemplating in my head. I think for part 1 we definitely do not need to keep track of the path. We just need to keep track of the shortest or the lowest risk level of the path that reaches a given point. So I think we can just do Dijkstra by the books. What do we need for the Dijkstra? First we need to parse this thing. It is a dense matrix, so maybe... Are we going to use array 2D today instead of the map thing we've been using. What does an array 2D do when you fall out of bounds? It'll probably crash, right? Let's try that. 1, 2, 3, 4 array. Make that an array 2D. So that's just a fancy structure, a 2D matrix basically. Yeah, it's this function. Yes, and let's try to grab something out of it. If my parentheses will allow me. What do we want to grab? First element. And what does happen? What happens if we try to go outside of bounds? Index out of range exceptions. So that's something you don't have with a map. If you do try finds, this is something we do have with an array 2D. So I'm going to go with array 2D today and just do boundary checks. We know the length of the grid. So let's try to parse this into a 2D array. And that's it actually. That's all we need to do for parsing today. What would that look like? Actually, I think a for comprehension will be really cool here. For row in example. For column in example. Yield column itself. So that should give us every... no, that's not what I thought would happen. Wait, example is a string list. So this is a string and column is a wait, example. Yeah, okay. I need to loop over the row second time around, not the column. Okay, this is better. And we need a 2D array, so let's put that inner for comprehension into its own list. Now this looks better. Is this the correct grid? I think so. So let's put this in a 2D array, which allows for... I don't know actually, why is a 2D array better than a nested list? Yeah, I think indexing will happen way better than this. So this is what we will be parsing, or how we will be parsing today. Pretty basic stuff. It'll suit our purposes. Let's see if we can parse our example. Yes. Can we parse the large input? Yeah, it takes a while to print, but we can. Oh dear, it takes a long while to print. Okay. So now let's do a Dijkstra or a shortest path algorithm. What do we need for that? What do we need for that? Let's grab Wikipedia real quick. I remember something about visited nodes. But now that distance becomes like the risk level and not the steps we need to take, or the distance in the 2D grid, maybe that becomes a bit more interesting. So let's refresh. We've seen this month already. Where is the pseudocode? There we go. For every node, just put the distance to visit it to like something really high. Yes. While we have a queue of... What is queue? Let's read the English text first. Dist is an array that contains the current distances from the source to other vertices. Yeah, for every node in the graph or in the grid, we need to keep like the current minimal distance. That I remember, yeah. So that's from the start to the current vertex, and that's the best distance we know of. Ref array contains pointers to previous hop nodes on the shortest path. We don't need to reconstruct the path. But I didn't know that Dijkstra does it like this. Contains... How does that work? Where does it update? I don't understand that part anymore, but I don't think we need that for part 1 today. How do we grab... What's the main loop here? That's the part I'm not sure about anymore. Okay, so Alt is the important one. That's where we do something. What is Q? Q is just a set, so it's a unique vertex set. Okay, but for each vertex in the graph, what do we need to do? This is setup, while Q is not empty. Where do Q come from? Okay, there. It's just every vertex in the graph that gets added to the working list. And while we have stuff in the working list, grab a vertex with minimum distance. Wait. Oh yeah, and the first one probably grab... Yeah, okay. Oh, that was a recap from way back. So when we initialize stuff, we just put the distance to reach a certain location to integer.max value, infinity. Except for the starting location, that one is like where we are, that's a distance of 0. And then we can do some kind of for loop. We grab the one with the minimum distance up until now. Remove it from queue, what? Remove it from the work list, yeah, sure. And then for the neighbors of that thing, what is the current distance we would have if we would start from this distance plus the new path length or the new step we take, the risk level, yeah. If that's a better, if that's a shorter distance, then we figured something out. And let's not worry about the path itself. Let's not worry about the path itself. Is that correct what I'm saying? Do we use this in the algorithm somewhere? I don't think so. No, we only use it to reconstruct the path in the end, I think. Okay, we're only interested in the shortest path. That is true. We can terminate the search after if we reach target. Yeah, that's true. I don't even understand pseudocode anymore. This is Chinese to me. But I think I know enough to get started for today. So, what do we need to do? We need to build a queue or a work list containing all the locations. And every location maps to the best distance to get there. So let's do that. I'm just gonna call it literally queue. Which goes, yeah, let's generate all the pairs. Yeah, let's generate all the coordinates. So that is again a for comprehension. Yeah, why not? For x in, what is it? Let's extract, or let's save this parsed to the array here. Is it a grid? What do we call it in the exercise? Cave? Cave. Let's call it cave. So we have our cave. Let's figure out all the locations. What is it? I know there's like 2 dimensions. Length 1, length 2. I think we have squares, so it doesn't really matter. Yeah, so let's do the same for comprehension. Is what I'm doing correct? No, this is again the cave, and it's 2. Just generate me an XY tuple. This should be... No? We should start at 0, of course. This should give us a single list of XY tuples. So it's 8, 9, 10, and then we go to the next row. I think that is correct. And let's map everything to something with a distance. If it is... Nope, let's not go fancy here. So that's a coordinate. If coordinate equals 0, 0, then we have the coordinate and distance 0. Otherwise, we have the coordinate and distance infinity. Let's just use an integer. I think our paths will be maximum of what, 10,000? So that will be okay. That looks correct. Yep. So now we can do the extra, which is a loop, but let's do one step so we understand what we need to do first. Let's keep the wording of Wikipedia. I already got rid of Wikipedia. So I'm just gonna grab the minimum one. So Q min by second. Distances are the second part of the tuple. Yeah, so we get our starting point. Now we need to look up neighbors. And it's a 2D array, not a map, so it's a bit more complicated with boundary checks. So let's write a function. Neighbors in a cave given a location. I'm gonna call that xy. How do you do this? It's been years since I did boundary conditions. Can we go diagonal? We cannot. Cannot move diagonally. Okay, at most we have 4. I'm gonna use a fork operation with if things. So let's try to grab the thing above us. So that's x minus 1, right? And stay on the same column. This will not work if we get an x smaller than 0. So x has to be at least 0. What do we need to grab? Do we need the location? We need the location, yeah. Do we need the location? What are we actually doing here? We are looking for neighbors, and then we are saying, okay, that new neighbor, we need to find a better distance. Yeah, so we need to do need both coordinates and the value. So this function will just generate the coordinates. Yeah, and then we can take the rest of the stuff forward. What do we need to do to get... so this was above us. What do we need to do to get the thing below us? This won't work if x was the last element. Oh, I hate off by 1 kind of things. What does that mean? If we have a 2 by 2 matrix, we can have a 0x and a 1x. But we cannot have a 2x. And 2 is the length of the matrix, so it should be cave length 2D length 1. So x has to be smaller than, for example, a 2D array. X has to be smaller than 2. No, because it can be 1 and that is not okay, so it has to be this minus 1. Maybe we're going to have to check this thing. It's been a while. I have no idea. But if this is correct for the x's, then I think we can do the same for the y's. Let's test the snot out of this. before we proceed. So we have a neighbors function. Let's test it out. So let's make an array 2D, one we can understand easily. So the small example again. And let's find neighbors. Of that's actually maybe a bad example. Let's build a slightly bigger one. 7, 8, 9. That's a joke. I won't make the joke. And now if we grab neighbors of 1, 1, that should give us 4 neighbors, right? One is the central number, the 5, so it should give us 4 hits. Please give me something. I'm gonna count that as a yes, that's correct. Now let's try some edge cases. So what else do we want to see? 0, 0, that only has 2 edge cases, right? Or 2 neighbors. Oh yeah, of course. No, not of course. I thought we did something for that. Probably this. So x has to be a positive number. Yeah, if it's 0, we can do a -1. That is not correct. True. So is this still working? It is. Is this still working? It looks better. I'm gonna do all the edge cases here because I know myself. I'm gonna do the one for the 2. No, for the 4. That should give us the location of the 1 and the 7. So what is the 4? Row 1, first position. Should give us 2, 1, 2, 3 hits. Origin, yes. 1 below us, yes. And 1 to the right of us. Yeah, that looks correct. I'm gonna see 2 more boundary conditions. Maybe if we do the lower right corner, we have every boundary condition. So what is that? 0, 1, 2, 2, 2? That's 2, 2. That should also have 2 neighbors. Yeah, looks correct. I am feeling comfortable enough to proceed. And this took a whole lot longer than I expected because I suck at boundary conditions. See, this is why I always use maps. Then you don't have to think about stuff like this. But anyway. We have our neighbor coordinates. So neighbors in the cave for current. No. No? What is wrong? Current is a int. Oh yeah. So that's actually a current location, current distance. And if we use current location to figure out the neighbors, that will work. Maybe we need to send everything to the REPL. There we go. So we start here. The current distance is 0 because it's the starting point. And we initialize it like that. Yes. And these are the neighbors. Now we need to look up the distances in the neighbors. Do we already have a distance thing? Yeah, it's cube. It is Q. So let's do this. Let's grab those neighbors out of the... Oh no, we need risk levels and the distances. Wait, I'm getting confused. We have two different numbers here. We have a grid containing risk levels. And that's when you enter a space, right? So when you enter this, your path risk level increases by 4. So that's like the distance function used in Dijkstra. But then we have this Q, which maps a location to the best distance up until now. Now that I hear that, let's make that a map lookup table. But we need to do a min by. Okay. Okay. Let's keep the map ID and the back overheads. Come on, this is the extra. This shouldn't be this hard. Yeah, let's take it one step at a time. Let's try to rebuild the extra without having a Wikipedia of the extra next to us. What did I break? Okay, everything's still correct. Cool. So we have neighbors now. No, something broke. Oh yeah. I was aliasing or using the same variable name. Are you still with me, Visual Studio? Okay, it's back. I don't know what just happened, but my REPL got super confused. Okay, we're still in the green. Okay, so we have a best distance to get to the current location, which is current distance. Then we look up the neighbors. And then we calculate the new distances to get to those neighbors, which is the current distance plus the risk level of that neighbor. Yes. And if that is better than the distance we have right now for neighbors, or for that neighbor, that's a shorter path. So we remember that. Where do we remember that? It cannot be in Q because Q is something we are eating up for the algorithm, right? Okay, let's go back to Wikipedia. That's not going back to Wikipedia, that is killing my browser. Wikipedia. Extra. Let's also grab Advent of Code again. The thing that's tripping me up is that every step we take is not like distance 1, it's the risk levels. It's confusing me a bit. So actually the risk level, that's this thing. No, length, that's the thing. And this is the vector containing the best distances we know of. So that's the best distance we know of to get to the current node. And then we take a look at the neighbor node. Yeah, so this alt thing is the best distance we have for the new node, given the current path we're using. If it's better, we have a better distance. So I think we might also need a distance kind of do some extra bookkeeping. I think we're just not doing enough bookkeeping. We have like a working list or a set for working queue. When do we remove something with Q? Okay, we remove something from Q every time. Okay, that was what confusing me. This is our working list. So I'm just gonna rename Q to working list, and then we need something else. Shortest distances, something. Which is a map that maps every location to its shortest distance. That's something we did not have. And that's something we will be needing. And we can just initialize that to 0. No? What? Distance is the infinity thing? How do we add stuff to Q? Okay, Q is just a list of everything. I should have read the algorithm. So this is Q. This is distances. That's what you get. So working list is just a set of everything we have to visit, right? Q is just an list of vertices or a set of vertices, yes. And distances is something separately, which maps every location to the best or the shortest path length to get there from the start. Yeah, okay. That's better. So, current location is the minimum thing. Work list, we don't need to do min thing here. We need to grab something out of working list. What? With the shortest distance. How do we do that? How do we do that? Yeah, this thing. So we need to grab the vertex in our work list that has the shortest distance. Distances are in here. So let's filter distances contains the entire universe. Yeah, so let's map. Let's make distances a map, sure. So it's a lookup table where we can relate a location to the best distance we have. Yeah. And then we say, okay, working list. Let's do a lookup in that distances map. And we need to minimum. No? I thought this was what I needed. Working list is a set of what is working list? A list of locations, yeah. So let's write that out in a full lambda. The exhaustion is starting to get to me. It's been a heavy week at work as well. I feel that it's not going as smooth as it should go, these Advent of Code puzzles. There we go. So I think now we have the next location to work on. I think so. Then we find the neighbors. That is also correct. And then we need to figure out the new distances for every neighbor. So that is something we can do. No, let's do that separately so we can debug when necessary. So let alt neighbor distance. Let's keep it in the same language as the algorithm on Wikipedia. So for every neighbor of the current location, we need to do something. So what do we need to do? We need to calculate the potentially new distance. Which is the current location, or the distance of the current node. So let's also grab that. Doing a bit of double work here. That's exactly what we're doing on top. That's not what I wanted to do. So this should give us 0 for the first one. Yep. So that is the distance for the current location. And we need to add the risk level of the neighbor. So what is it called? Grid? Do we have the grid here? Cave, sorry. Cave at the neighbor. And neighbor is a tuple. So let's grab their component parts so we can index it. I am actually, now that I see all this, I should have just stuck with a map instead of a 2D array. I am regretting my decision. Cave XY, that should return a... That's a character array. Okay, let's parse that thing not into characters, but into numbers, shall we? So let's parse character into a number. I'm gonna go a bit sideways here and pass through the string world, because otherwise we'll get the ASCII values. And I don't feel like writing system.in32.parse, so this will work probably. Let's verify that. Do we now have a list of numbers? We do. That's better. We were somewhere down here. So does this look like new neighbor distances? Are the distances 1 and 1? 1 and 1, yeah, it could be. So we take the distance to the current location plus the risk level at that neighboring location. And if that is better, than what we know for those neighbor locations, we update our distance map. So let's fold. Let's write a function update best distance, which gives as input this. This is a list of the neighbor locations and the alternative distances. So this thing also needs to know about the cave. And the initial state, or the thing we are trying to update, is the distance lookup. That's a map. Is that what we want? Sure, let's try it with a map first. And so we have an update best distance function. Let's write it somewhere. I'm just gonna write it right around here and we'll move it around. And so we have a cave. We have location and alt distance, and we have the... Do we need the cave? Do we need the cave? Let's get rid of the cave. Do we need the cave? I don't think we need the cave. Fold takes the state. Okay, so first it takes a state. That's why my compiler is complaining. Argument order matters. There we go. So we are just aggregating over the neighbors now. And we are trying to update the distances. And this is one of those neighbors, which is a location N here and a new alternative distance. So let's find the current best distance, which is a lookup of location. And if alt distance is better, then we return the map. Oh, autocomplete, what are you doing? And then we turn the map and updated alt distance. And otherwise, we leave the map alone. Sorry, what just happened? I pressed save and a line of code disappeared. That was weird. Then I think this might be what we need. Does this look good? So we have visited 0, 1, and 1, 0. This looks correct. Where's my 1, 0? Let's try to look it up to make sure that also changed something. It's a 1. Yep, looks correct. And how many things did we change? 2 neighbors? 1, 2. Yep. I think this might be it. So this is one step of the algorithm. Yeah, and the entire thing is starting from here. I'm going to grab update best distance and put that somewhere far, far away with the rest of the functions. So this is parsing, this is building a work list, this is building the distance list for Dijkstra, and this is the actual Dijkstra algorithm. Let's call this updated distances. When do we know we're done? If we're going to put this in a recursive function, it ends when? It ends when? When queue is empty? So we might want to get rid of... Yeah, let's do when queue is empty, but we can shortcut it if we find the end state actually, right? But we need to update working list. What is working list? A list of queues? A list of queues. Let's make that a set actually. I don't think we'll ever get duplicates in there. But now we're sure. Can I do sec minus by? Is there a set minus by to make it explicit? No. Okay. Let's keep it a sequence. So new working list is the current working list without the current location. We don't need to process that one again. And then we can do a recursive call with the next working list and the updated distances. So I think we're ready to... Yeah, I think we're ready to write a function here. Working list is an input argument and distances is another one. And probably the cave is as well. So let's make that explicit, that dependency. There we go. And what does this thing return? Let's first do the recursive call, so shortest paths. No, let's first do the halting condition. If our working list is empty, then we're done. What are we going to return? Distances, sure. Otherwise, we're going to do a step in the algorithm and call itself recursively. So that is a recursive function. We should mark it like that and do shortest paths. I have the feeling this would have been 10 times easier in Python, and I'm I don't know why. Probably because I'm tired. So let's do the recursive call here with the cave as we know it, the next working list, and the updated distances. So I'm going to call that updated working list as well. So everything is named the same way. So the original cave, that never changes. We have tweaked the working list, yes. We have tweaked the distances, yes. And we have tweaked it with this best distance magic. Cool. I think if we now call our shortest paths with our cave, our working list, original working list, and our original distances, I think that's it. So let's grab those. So all functions are on top and everything we execute is down here. What will this return now? The list of distances. We need the distance of the final thing, right? No. Do we still have out of bounds? I thought we tested the snot out of that. What's going wrong? It's in our shortest path. What is this thing? Invoke tuple 2. Invoke tuple 2. What does that mean? What are we doing? Cave XY? Is that what's going wrong? It shouldn't. It should not. Yeah, that's the only thing we're doing actually. It is going out of bounds. How is that possible? Nope, I don't see it. Let's troubleshoot. Sorry. Let me first take care of something completely unrelated. There we go. Yeah, completely unrelated thing taken care of. So let's troubleshoot this thing. We have out of bounds. Let's start looking at what is happening. Are we sure that it's happening here? Pretty sure. Let's put some debugging in here. I'm just gonna do a debug statement. By printing out whatever we get in here and returning it back again. There we go. So now we should see what is passing through this pipeline. And we have a 10 by 10 grid. We have a 10 by 10 grid. So what is going wrong here? Wait, what? 09. 09, how can that not be a thing when 110 works? Color me confused. Let's actually do something else. Let's also put print after. Yeah, let's print before and print after, because I'm still having a hard time believing that this line is actually causing the error. Let's make sure of that first. Yeah, there's a problem with 09. And it's an index out of bounds. So cave, dear cave, why don't you have a 09? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's print out the grid. Or the cave, sorry. I still don't see the problem. Are we accidentally updating the cave? This will be a bigger trace, but let's see what we get here. Okay. Can we crash somewhere else? Are we crashing inside shortest path for sure? So neighbors cannot be the problem, right? Neighbors doesn't do anything, that just generates tuples. Yeah. Okay, what is going wrong here? Why is 09 a problem? Can we do that exactly, that call? Can we do grab element 09 out of the cave? What? So row 0, column 9, it should just grab this too, right? I'm not seeing the problem here. Or I am seeing the problem, but I don't understand why it is a problem. So this is row 0. Let's see here. So we are definitely in this part. So before we handle 09, I'm thinking, do we mix up X and Y coordinates? Don't think so. This looks correct, this looks correct, this looks correct. Y, Y, X, X. Changing X, changing X, changing Y, changing Y. But even so, we have this coordinate, 0, 9. Nope, still not seeing it. Let's continue debugging. Risk level at a location should be a certain number. So it's X, Y. And the risk level, let's not print it out just now, because probably that's where the problem lies. Okay. And let's maybe only print debug stuff if we are in the 0.9 case. So if location equals 0.9, then print something. Yep. Let's also do that here. Let's rename n to location. And let's do that thing here as well. I love me some debug-driven development. We'll get rid of this madness in a second, but I just want to find the problem first. Okay, now we're back. Working order, cool. I had some trouble putting in those debug statements. Pipelines are awesome, and I think modern IDEs like Visual Studio 22 have decent support for debugging pipelines. But there used to be a time where there was no support for debugging pipelines, and this thing was the only thing you could do, or like extract temporary variables to troubleshoot stuff like that. It's a bit the same as with C# link queries. When people get creative with those, it's a pain in the ass to troubleshoot if you have a bug in there. But anyway, let's soldier on. We've been working at this for an hour. It's a silly shortest path algorithm. We should be able to solve this. Sorry, why is there an after? Whoa, that's even crazier. So we visit 0.9 once. It works. We visit it twice and it works. We visited a third time and it's... Is it correct that we visit 0.9 multiple times? We should at most visit it 4 times, right? Should we visit it at most 4 times? Yeah, because we can enter a certain location in the cave from 4 neighboring states. And in the worst, or even in the best case, we visited from those 4 directions. So why is it working 3 times and not the 4th? The grid never changes. Grid never changes, does it? Let's just print out the risk level as well. There we go. What is 0.9 again? First row. So it always should be 2. Or in my head, it always should be 2 at least. What is going wrong? Okay, let's clear our console. Let's run that one more time because I I want to be super sure. Okay. So first time we visit location 09, we say, hey, yeah, we found it and the risk level is 2. That is correct. And then that is 1 iteration. We do it the second time. All good. We do that a third time. And somehow it crashes with an index out of bounds. And we don't see the print of risk level at. So this is the problem. I'm gonna make super sure by just hard coding it. Now we should see that print statement pop up. If that's the case, then that array index for some reason is not working. My foundational programming beliefs are being shaken by their core. Oh no, it's actually not a problem. Huh? Now I'm even more confused. So we see this print. We don't see this print. How is that even possible? Did I not send the correct thing to the REPL? No. It's making no sense to me. Should we try debugging? I have never debugged F# code in a REPL. How do you do that? The current interactive session is not configured for debugging. For the best experience, enable debugging in interactive sessions. What? Enable debugging in F# interactive settings? Where are those settings? Let's play around with it. Advent of code is like a month of learning, so let's learn. Oh cool, there is a enable script debugging thing. I have no idea what that does, but let's try it out. Maybe the times of print-driven debugging for F# are over. That would be cool. I can tell you that it's way slower. I sent my code to the REPL an hour ago. Okay, there we go. Will it break on exceptions? It does not break on exceptions. Let's start our debugger then. Which is a super painful process, apparently. Okay, there we go. This is the first time I have seen a debugged REPL. So let's see what this gives us. Nada. Okay. Let's make sure we break on exceptions. It is not breaking on exceptions. Am I being too fast? Is that a problem? No, I am seeing it blow up in my REPL. I am debugging. I am catching or breaking on all CLR. Is it not a CLR exception? Index out of range is a CLR exception. So why is this not breaking? This is... No, I don't like what I'm seeing here. Let's put breakpoints in here, but I doubt that will work. What is it saying? Breakpoint will not be hit. No symbols have been loaded. That sounds promising. Yeah, no. This debugging thing probably works very well for FS code or code in F# files, but for scripts, the way I'm solving Advent of code, I don't see what I'm doing wrong here. I am debugging. I have put on breakpoints. That is not working because those symbols have not been loaded. But I would expect if I check this thing, like break on all exceptions, and when I see an exception in my REPL, I would have at least expected it to break. Maybe let's try one more thing. Let's reset. Ah, now it's broken again. Really? Okay, I'm gonna try this one more thing because it's completely new to me. Sorry. It's not configured for debugging. I literally just changed that in my options. It's literally saying enabled script debugging. Yes. Visual Studio, you disappoint me yet again. This looks like a problem. This looks like it shouldn't be saying this. Reset the session. Okay, we're gonna do this a third time because I am of good faith. I'm gonna explicitly tweak this variable again. So yes, you can debug scripts. Dear FSI window. Then we're going to explicitly reset this REPL thing. Which is not doing a whole lot. I'm gonna reset it just once more. Oh. Something I did changed things. Maybe it was the not pressing enter. Press enter to start. Maybe it's that was the problem. You learn something every day. Send everything to the REPL. We won't be winning any speed records today. I think everyone will be quite done by now. Really? Really? Can I put a breakpoint in now at least? I'm approaching like... No, I cannot put a breakpoint now. I'm approaching rage quit territory here, so I'm going to have to persevere. Yeah, this is not working. We gave Visual Studio debugging a try. It is not the best experience for F# scripts. I'm going to forget I even tried it. There we go. So let's do this old school. I have thoughts. I have thoughts on support for one of the native .NET languages in the native editor, but I'm gonna save those thoughts for me, myself, and I. So we are back at square one. Why is this not printing? Risk level at. Risk level at. Is it this ass thing? I'm starting to doubt everything. Yeah, when in doubt, figure it out. I don't see how an ass thing can give me an array out of bounds. So that's probably not a problem, but I'm getting paranoid. I'm getting paranoid, sorry. So I'm just gonna try it. These are like the beauties of programming, you know? You've been working or programming for a decade now, and you get like these weird exceptions that don't make sense in your head, and then everything grinds to a halt, and you're stuck with something. I have that at least once a day. What are we seeing here? But most of the time I just call like one of my colleagues, hey, I'm stuck, can you take a look with me? So I'm hoping, chat, that you can be my pair buddy for the day. Because I'm super stuck right now. What is happening? What is happening? So I got rid of the alias. So now it's just this thing. How can we have an index out of bounds? You see this print statement? We don't see this print statement. This confuses the hell out of me. Is it crashing where we think it's crashing? If it's crashing like using this debug output, then we see this thing, B409 in the entire cave. We don't see this thing, which in theory should mean something in here is breaking. That makes no sense. No sense whatsoever. So I'm guessing here, but why am I not seeing this risk level add thing? Is it a console flush not happening again? I hate it when my basic assumptions are like violated. No. Oh, come on. You know what? I think our debug driven thing is not pinpointing the correct location of the bug, so I'm gonna verify that. My best guess is that this is crashing. Yeah, my best guess is that this array index or this access of a element in the 2D array is crashing. Don't know why, because it looks like it's doing the correct thing. Even if it would do the opposite thing, it'll end up with a different 2, but it would still not crash with an out of bounds. I have just talked myself out of believing that this is the problem case. That's not good. Yeah, let's make very, very sure. I'm gonna print every array access we do. Looking up a location in a cave. That's an array 2D. Apparently we have to help it. What's the type signature again? Something like this? I think so. This is real paranoid me. It's been, I think, months since I had to do something as painstaking as this. It's not pleasant, but it's part of the job, I guess. So this is, I can't get any more literal than this without a debugger. So let's use that one as instead of the direct access here. Do we do we access that array anywhere else? Why is this currently broken? Did my refactoring break something? What is this green squiggly? Oh yeah, we need arguments. That's what's wrong. So we have location and cape. Do you compile now? No, you don't. Now I am confused again. This looks correct, right? Yeah, that looks correct. It takes a cave, it takes a location, and it returns a risk level at that location. What is the problem here? Parentheses, maybe? Yeah, parentheses. Okay. That was silly. This will print out even more. This will print out a whole lot. Boom. And there we go. Oh, where the hell is it getting 110? What? There is a 110 in there. How did the 110 slip in there? And why did we not see it in the printout? $110 is a problem. Anyway, I thought we covered that case. Is it getting the 110 from here? Probably. So that is probably a neighbor of 09. But before, when we print that string before, this is already inside a list of neighbors, yeah? Yeah. I don't understand how it never printed out 110 before. Prints out 110 and the actual indexing. But we don't calculate anything. We just do location, location, location. And location is coming from the list of neighbors. Okay, at least we found the problem, but I don't know why my debugging magic didn't actually catch it. I'm gonna get rid of that printing madness. Because we know what the problem is. Am I going to regret getting rid of this printing? Probably. But so be it. How did we end up with a 110? Let's print out the neighbors. Well, this was interesting. We are printing out way more than just the neighbors. These are neighbors. Yeah, we have 09 and a 110. I'm also going to print out the current location just to make sure we debug the correct case. Neighbors. And let's not print out our array indexing because we found a problem. This bug would have been way easier to solve with a semblance of tool support. There we go. Oh, we actually grabbed the point and not... Oh my god, I think I know. Ouch. Stupid bug. Where we build the work list for Dextra. Son of a... Our work list is too big. We should not... Oh, that's a stupid bug. But it's my own fault. This is better. Can you please just print out the entire thing to make sure we fix the bug? Yeah, this used to be a 10, now it's a 9. That will be better. Silly mistake. That cost me what? The better part of an hour? Half an hour? Okay, let bygones be bygones. We found a problem. I'm going to get rid of all this troubleshooting magic. We'll introduce it again if we need to. So this is where our code was at. We need some extra parentheses. This is where our code was at before we went down a off by one error bug hunt. Okay, my rage quit level has declined. I think we can continue now. Let's grab whatever we get. Cool. We need to figure out the distance to bottom right, which is paths map dot find, what is it, 99? Haha, not 1010. We tried that. I totally forgot what the actual output should be. The total risk is 40. That looks correct. Please let part 2 just be something with the actual path. That would be a minor tweak. Gonna wrap everything into its own function again, or into one major function. There we go. And I think we need to change what we parse again. Yep, that will probably work. Let's verify it again on the example. $40. Yep, I'm gonna put that in a test because today was something. Today was something, I tell you. For me personally, this was almost as hard as day 14 part 2. I'm just gonna run everything just once more. If it feels like doing it at least. Having a NuGet download in the middle of your script always slows down reruns. Okay, that works. Solve example should give us 40. Yes, solve input, which is our actual input, that should give us something probably slightly larger. It's burning my CPU. I did not think this would be a problem today. Interesting. Don't tell me I have to optimize the algorithm. What could we optimize? I'm not sure actually. Every axis I see is like logarithmic or constant. We do map.finds, those are logarithmic. Set.remove, also very fast. Set.isEmpty, also very fast. Maybe this update best distance thing is not the smartest way to do it. Maybe not. Wow, it's taking a really long time. I thought like by talking over this for 10 seconds it would find... Oh! Yeah, it's not the top right corner for our big grid, so that's a small bug we have. But it appears to not even halt. That's worse. Let's take a look at what's happening. Let's first fix the bug here. So it's not 99, that only works for the example. It's the... Yeah, let's do this again. So this is the maximum dimension. Let's grab that in a variable. So it is the cave array to the length 1 minus 1. And we can use that variable here, 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 and here. So this should still work for the example. I think I'm gonna give it 10 more minutes and then I have to get ready for work again. I hope to solve part 1 at least. Otherwise it's going to be 2 losses in a row, like 2 bad days. I don't know if I'll ever recover. Of course I'll recover. I'm still having fun, don't worry. It's a bit of a bummer, that's all. Cool. So solving the example, that should still work. Yes, we can solve the example. Let's print out. Let's print out. I've had a bad track record with printing out, but I'm gonna print out. What am I going to print out? The length of the working list. Are we going towards the end here? Yeah, let's do a set.count. Whoa, 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 whoa. Auto formatting, I love you, but I don't love you when you do this. We still have to process locations. Maybe my script file is getting very big and the formatter is fighting with this amount of code. That could be the problem here. That's maybe a good smell. When my IDE starts to crash because of auto formatting, I have to split my code up into multiple modules. Good heuristic. Let's take a look. For example, this appears to be correct, right? Yeah, we start with 100 location. We nibble one with every iteration of Dijkstra, and in the end we have something. Let's do this for our input now. Let's clear the console. Look at it go. It's just very slow. Why is it this slow? I must be doing something like very suboptimally, even with my personal masochistic constraint of not introducing mutable state for these challenges. We should be able to figure out a faster way than what we're seeing here. What are we doing for every iteration? That's the shortest paths thing, right? This cannot be the slow thing. Profiling F# code. If we cannot even debug F# code, profiling it, I don't think we'll get there. So let's do the profiling in our head, although that's not something I recommend for production use or for real life use. What could be improved? This is pretty bad, I think. This statement is pretty bad. This is always like a complete loop over the working list, and every time for every element in the working list we look up the distance. What if we smoosh those two together? So working list is not only a... No, that won't work. But I think this might be a performance hit. This is a small performance hit because we already did the exact thing here. But that's only for one location, so I don't think that'll be a problem. Neighbors, that's a really fast operation, right? We don't do any lookups there, we just do some plus minus thing. Yep. Removing something from a set of 10,000 elements should not take that long. Neighbors are at most 4 every iteration. So doing a map should work. Doing a array index that's constant time should also work. This fault thing, that's the second part that probably hurts. So I see 2 potential hotspots without profiling. What is update best distance doing again? Another... Wait, we're doing another lookup of distance for the neighbor. Yeah, I think we're doing a bit too many distance lookups. I think we could streamline it. But only by a factor of, what, 4? I think? Not by a factor of fast enough to to fix this algorithm or to fix this performance. Map.add. How fast is that again? Let's look it up. I think logarithmic. It's a yeah, probably F# map.add performance. Will we get somewhere with this Google query? Stack Overflow, yes, but is there no official? There we go. F# collection types. Is the site slow or is my computer slow? Okay, there we go. Yeah, so everything you do with a map is logarithmic. Except for filter, which makes sense. Filter you need to process everything. Bold as well. We are doing ads, and what is the other thing we're doing? Finds. Finds is logarithmic. Ads are logarithmic. Yeah. Don't think that I can change something without changing data structures. I have only 4 more minutes left today, so I'm just gonna acknowledge my loss or acknowledge defeat, or at least for a short while. I'm gonna let this run out while I grab some breakfast. Hopefully it gives me the correct answer first time. And maybe part 1 or part 2 is finding the actual path instead of only the distance. That's only a minor tweak. But again, we'll have to do that later. Thanks for watching. Thanks for tuning in. The last pair of days were like not really easy, but I am learning new stuff, especially stuff about support for tooling for F#. And I hope to see you again tomorrow for day 16 or later today if I find the energy to get some extra stars we have been missing out. Bye bye.